Today we would like to talk about the effect of the titanium concentration of the structure, optical and electrical properties of the aluminum and titanium coated zinc oxide thin film. Our group have Virasat Patomtat and Hasawat Udom Chalansat. Nishapat Susikai and Nasakon and Nathan Sing sweet.
That's a year.
I have divided my presentation into a 4 part. Introduction, experimental, result and discussion and conclusions. Okay, the introductions. Optical and electrical properties of zinc oxide compound have been extensively studied as an electric curatory of transparent conductor or semiconductor materials. They have been used in the wave fields of the applications such as the solar cells, lighting, the light emitting diode, the flat panel display, and thin film transistor. The zinc oxide is a semiconductor with a hexagonal precise lattice structure in a compression of the indium titanium. It has a profitable properties of the high transmittance, high chemical stability, non-toxic, and low cost. And in this studies, the aluminum titanium zinc oxide thin films has been grown on the glass substrate on the bisolder metal. The influence of the titanium doping concentration on the structure, optical and electrical properties of the symbol were investigated, and the optimum concentration of titanium were determined according to the resistivity and transmittance value on the thin film.
Now, let's move on to the experimental. Before deposition, substrate will clean with detergent solution, then clean with acetone, deionized water, and ethanol. In this slide, show the solution for preparation of the precursor. Okay. Step 1. Mix 2-methoxyethanol as solvent and diethanolamide as stabilizers. Then add zinc acetate dehydrate, aluminum nitrate nanohydrate, and titanium tetra N-butoxide various concentration in the previous mixture. The mixture is the aluminum titanium zinc oxide precursor. Okay, the mixture solution was stirred at 70 degrees Celsius for 22 hours. The solution becomes transparent and homogeneous. Next step is deposition of aluminum titanium zinc oxide precursors on the glass substrate. In this figure, show the dipping substrate in the aluminum titanium zinc oxide precursor. In this method, using the viscosity of the precursor solution and deposition speed. When finished, we'll dry at 300 degrees Celsius for 15 minutes. And with the heating rate is 3 degrees Celsius per minute and 5 times per sample to remove the organic residues. Finally, we'll sample with onions at 550 degrees Celsius for 2 hours.
For the characterization of thin film, our first form, what is process? such as X-ray diffraction analysis, scanning electron microscopy, spectroscopic electrometry, atomic force microscopy, and advanced spectrophotometer. X-ray diffraction pattern using to investigate the crystal structure. The morphology of sample was observed by scanning electron microscopy. The loudness was observed by atomic force microscopy. The optical transmission measurement to refractive index, extinction coefficient value, and can indicate thickness of thin film. And that is used. That is. Okay, sorry. Back. Again. No? Sorry. The optical transmission measurement was performed by advanced spectrophotometer. That's used spectroscopic electrometry measure to refractive index, extinction coefficient value, and can indicate thickness of thin film. Result and discussion. This figure show that the X-ray diffraction pattern of the sample include agreement with standard data from JC-PDS. It is obvious that all the synthesis sample are single phase.ให้เวลาต่อ5 นาทีครับ Okay, peak in X-ray diffraction can indicate a crystallographic plane and show that the film have good crystalline structure. For the comparison between of the sample, it was found that the peak intensity were decreased when the increase of titanium concentration. This reduction due to formation of structural disorder arising from titanium incorporation, especially the gain boundary and restriction of the crystal growth. Moreover, they have seen the position of peak small shift to higher angle due to the substitution of zinc by aluminum or titanium that lower side atomic. The crystal size can calculate by shorter formula this equation. The crystal structure is listed in the table. The crystal structure decreases when the increase of titanium concentration, and you can calculate the lactic parameter by back law. It will know this equation, and then A and C lactic constant of hexagonal Versailles crystal structure can be identified following to this equation. So lactic constant also decrease when the increase of titanium concentration.
And next is the results of the ATCO thin film surface morphology. From picture A to D is the ATCO thin film with 0.2 to 0.5 atomic percent titanium respectively. You can see when increased, You can see when increased titanium content, the mean grain size was decreased due to titanium cation in zinc oxide structure help to create more nucleation center and agree with its RD result. For the thickness of the sample with 0.2 atomic percent titanium, about 220 nanometers, and in the cross-section image of these samples, you can see the surface is uniform and film is dense compact. For the roughness of the ATCO thin films can observe by AFM images. Each image shows the samples with different titanium content. From picture A to D, you can see reduction of roughness and more smooth surface upon doping with titanium. In this figure, plot between RMS roughness and titanium content, you can see when increased titanium content lead to RMS roughness decrease from 8.2 to 3.4 nanometers, and according to AFM images, and relate to grain size reduction in previous result. In this figure show the transmittance spectra of ATCO thin films with different titanium content. The sample have transmission in the visible range and have maximum value about 86%. So the samples are transparent in this region. When compare all the samples, you can see when increased titanium content, the transmittance decrease. Indicate that the transmittance depend on microstructure features such as grain boundary, which can scatter more. If more titanium content, the sample has more grain, so light will scatter more, and moreover has a blue shift in absorption edges in the samples caused by increase in carrier concentration of thin films. And for this equation, used for calculate to absorption coefficient for a direct bandgap semiconductor. FD is the thickness and T stands for optical transmittance.
In this graph, show the variation of the energy in the unit area versus the photon energy in the absorption regions, and this can be explained by a task model in the equation. Where Hv is a photon energy, A is constant, and alpha Hv is a photon energy in the unit area. You can see the titanium substitution led to increase in the optical bandgap of the sample. In the 0.1% titanium, it has an optical bandgap of 3.26 electron volt, and in the 0.5% titanium, it has optical bandgap 3.31 electron volt. Its widening of the optical bandgap is generally resolved from the filling of the electronic state near the bottom of the conduction band. The Fermi level was left into the conduction band. The titanium substitution led to increase, made the widening of the optical bandgap is improved too. And in this graph, show the variation of the refractive index of the wavelength upon the titanium substitution, and it can be explained by the Crunchy's model in this equation. Where A, B, and C is the Crunchy's coefficients. For all the thin films, it have the refractive index increase entirely in the wavelength from the 250 nanometer to the 350 nanometer, and then decrease in the wavelength from 350 nanometer to 800 nanometer. And it can attribute to the increase and decrease of optical. Respectively, the refractive index decrease gradually upon doping titanium. It's what mentioned before that titanium can act as active N-type donor to generate free charge carrier enhancement of titanium among causes the increase in the charge carrier concentration in the zinc aluminum oxide film increase. The observed decrease of the refractive index may be a result of the increase of the carrier concentration.
In this graph, show the evolutions of extinction coefficient in the functions of wavelength that can follow by formula. The coefficient will high in the ultraviolet light with the 300 to 380 nanometers of wavelength that can see in the green light on this slide, and extinction coefficient decrease in the 400 to 500 nanometers of wavelength that can see in the blue line on this slide. Okay. The extinction coefficient refer to the light absorbance. That means the law of coefficients. Film can't absorb a field of light which light can transmit it, so we can see the transparent film. Considering that atom of titanium is 0.1%, will causing the lowest extinction coefficients that compare with all sample, or can conclude that the aluminum titanium zinc oxide being filmed with 0.1 atom percent of titanium will be the most transparent. That can see in the red square. The resistivity is the specifications of materials. In this table, resistivity increased with increasing in titanium concentration, may be due to increasing in atom of titanium that resulting to a large number of charge carrier that's causing to stress field. As we know, resistivity sensitive for the defect on the grain boundary such as carrier and oxygen vacancy. And from XRD, from the results of XRD, FE, SEM, and AFM that confirm the decreasing in crystal size, all cancers will have a lot of grain boundary, which the microstructure defect, free charge carrier, which the microstructure defect will block to movement of free charge carriers and reduction mobility of them. That cause to increasing in resistivity. The 0.1 atom percent of titanium will show the lower resistivity, or I can say the higher conductivity.
In conclusion, The social technique used for deposit aluminum titanium zinc oxide thin films on glass substrate. The samples was confirmed as the zinc oxide hexagonal versatile structure. The grain size and RMS roughness decreased upon doping with titanium. The band gap have more broad could attribute to the Bernstein-Moss effect and the refractive index decreased upon doping with titanium. The increase in the titanium content affect to the resistivity increase. Meanwhile, the transmittance decreased. According to the resistivity and transmittance value, it was concluded that the optimal concentration of titanium in aluminum titanium zinc oxide thin film equals to 0.1 atomic percent. Thank you for your attention.
Good luck.